Okay, so we're looking at the geometry review. We're going to look at starting with cubes and cube roots. Just a reminder that how we should really frame cubes and cube roots. So cubing something is, cubing, going to the left here, is taking a length and converting it to volume. Cube rooting is taking the volume and converting it into length. So in this case, x would represent the length going this, the volume going this way. X in this case represents the length going this way. So the length, when we cube it, we end up with volume. Okay, the volume when we cube root it, so when that x represents the volume, we cube root volume, we end up with length. So make sure you have that kind of geometry in mind when we're thinking about cubes and cube roots algebraically. So when we talk about the number line, we know that these are all cube roots. What we can say, the reasoning we can say is that if the volume is smaller, the lengths have to be smaller. So these cube roots all represent lengths. Inside represents the volumes of the cubes. So if we have a big cube, we're going to have a long length. If we have a short cube, we're going to have a short length. So if I were to put them on a number line, the cube root of 5 should be smaller than the cube root of 27. That is a perfect cube, so we should know that that actually is equal to 3. We know that that should be smaller than the cube root of 81. The cube root of 81. Okay, that is not 9 because that's the square root of 81. We know that that's got to be smaller than the side length with a cube of 100 cubes. And we know that if we have 125 cubes, the side length is going to be 5. Okay, and it should be in that order on the number line. Okay, so again, with squares and square roots, make sure we can put the length and areas into the right parts of the diagram. So the length is square root of 22 centimeters. Okay, so square root 22, that would be a length. That would make the area 22 centimeters squared. Okay, so that 22 on the inside represents an area. We square root it, we get length. Here, this 81 centimeters squared represents area. Okay, and then the side length would be the square root of this. So if I want to do that, I can do square root 81 centimeters squared, which we probably should write as 9 centimeters. Okay, so make sure we're able to put those into our diagram.